All right, hello students. Today we are going to talk about quadratic functions and again revisit that format that we learned, or that formula called vertex form, where y equals a times p, x minus p squared plus q. Because we haven't talked about one thing about that format yet, and that's when the a value, or the number in the a position, is not a positive one or a negative one. So what happens if it's more than that? So the idea of this lesson is for you to actually investigate that. So try things out, try changing that value, and see if you can figure out what the effect is. And I'm going to use the notes to help guide our discussion in this and to help guide you into figuring out what those changes are. So that is, it looks like this. It's lesson 2. And it is your page 68 in your note package. So we're talking about expansions and compressions. So if we were to take the basic model of the most basic parabola, it's y equals x squared, and we already investigated that. And this time we're going to look at what happens when we change the number in this position. So instead of that being a positive 1x, what happens if we make it a larger value than 1? And what happens when we make it a smaller value than 1, regardless of sign? So a number of ways you can do this is do another table of values, -2, -1, 0, 1, 2. If you have a graphing calculator, you can go into the y equals function. I am going to try to incorporate graphic calculators in Unit 6. There's an app you can download to actually use what is an actual graphing calculator. There's a couple of apps you can do too, but those ones cost money. And there's also an app called Desmos. It doesn't look quite like a graphing calculator. It is pretty handy in doing quick graph sketches. But the downfall of that is if you learn how to use Desmos, you still have to learn how to use a graphing calculator for Pre-Calc 12 in university, because they won't let you use Desmos because it's on your phone. All right, so, but when we're sketching it and you're not using it to solve, that's fine. So you're going to do a table of values, putting in numbers in for x, remembering that you always have to follow BEDMAS. So this first one, our equation is y equals 3x squared. If we replace that x with a -2, the -2 gets inputted or substituted in brackets. And then we have to follow our order of operations. So you do brackets first. There's nothing to do in the brackets. And then the next thing you do is exponent. So you have to do that -2 squared first. This becomes y equals 3 times -2 squared, which is +4. Okay. And then you do your multiplying. 3 times 4 is 12. So when x is -2, y is 12. Okay, pause the video here and do the other values and see what you get. Should have gotten 3, 0, 3, and 12. So if this here is a sketch of the most basic y equals x squared, the model parabola, and then you were to graph y equals 3x squared, you're going to find the vertex is in the same place as it should be, because there's 0 in for p and there's 0 in for q, which gives us our vertex values of 0, 0. And you're going to find that it is squished. It's like this squish thing, and you can't even get the next points on the graph. It looks like this. So this one in red is my y equals 3x squared. So what we call this is, if you were to horizontally come in from the sides and squish the parabola, that you would get what looks like the red parabola. So we say this parabola is horizontally compressed. Horizontal compression. There's another way we can talk about it. We can also say it was vertically stretched. So if you took it vertically and stretched it vertically, that's also what we have. So this is also called vertical. Move my face out of the way there. Vertical stretch. Okay. Another word for stretch is expansion. Except for it doesn't really look like an expansion in this case. Vertical stretch seems like a better fitting description for what goes on here. Okay, that's just not looking very good at all, is it? So you know what I mean. It's vertical stretch or vertical expansion. I'm gonna use my face to cover up that really messed up writing. Okay, so what happened? It became narrower, which we call a horizontal compression. It's horizontally compressed. Okay, which is the same thing as vertical stretch or vertical expansion. These last 8 little things underneath the line are kind of a review of lesson 1. So the domain is X is all real numbers. Pause the video here and see if you can do these, because hopefully by now these are getting a little bit easier. The range is Y has to be greater than or equal to 0. The vertex happens at 0, 0, because there's 0 in for P and 0 in for Q. The x-intercept happens at 0. There's only 1 because it just rests right on it. It is a min value that happens when y equals 0. The y-intercept is also 0. The x-axis of symmetry happens at the x value of the vertex, which is 0. And it is a compression, horizontally compressed. Usually we talk about if we're saying is it compressed, is it expanding, we're talking in reference to what's happening horizontally, not vertically. All right, so we're gonna do the same thing for example 2. I want you to pause the video here, put in some values for x and calculate y. To help you out, why don't you use negative, ooh, no, that's not helping you out at all. I'm not sure why it keeps doing that randomly. Use -4, -2, 0, 2, and 4. Okay. And join me after you're done those. Okay. So if this black line is the model parabola of y equals x squared, we're going to put in the values for when y equals 1/2 x. So remember, when you substitute in brackets, you do your exponents first. So -4 squared is 16. And then you multiply it by that fraction. So that's the same thing as 16/2, which equals 8. So we're going to continue doing that for all the other values. And we're going to plot those on. So the first one, when it is 2, it's 2. And when it's 4, it's 8. Okay. So in terms of what's going on horizontally, it's like someone took it horizontally and pulled that parabola open more. So it's being pulled over there. So we say it's horizontal stretch, which is the same thing as expansion. You'll see both terms used, which is why I'm using both. Vertically, remember we usually talk about in terms of horizontally, but sometimes just to throw you out of your game, it'll talk about vertically. So in the textbook and in university, and you need to know that they're the same thing. So vertically what's happening is it's being squashed, it's being compressed vertically. So this is a vertical compression. Okay, so what happened? It became wider. And we call that, usually everything's in terms of horizontal, so it's horizontally expanded or stretched. Okay, the next part is a little bit of review. So pause it here and see if you can get these answers. Okay. The domain is X is all real numbers. The range is y is greater than or equal to 0. The vertex has not moved, it's 0, 0. That means that the axis of symmetry is when x equals 0 because it's the same as the x coordinate of the vertex. And this time it is still a minimum value, and the minimum value happens at the y coordinate of the vertex, which means that it has to be greater than or equal to 0. The y-intercept and the x-intercept are both 0 because the vertex is on the point of origin, and this is an expansion. Okay, so let's summarize the formula all over again. So this value for A tells us a lot of things. If it's positive, it opens up. If it's negative, it opens down. If it's a fraction, regardless of whether it's positive or negative, because that tells you if it's open up or down, you're going to have a horizontal expansion. And if it's an integer, meaning it's more than 1, actually I'm going to rewrite this in a different way. Opens down. If the value of A is less than 1, so that's saying whether it's positive or negative is less than 1, so it's between 0 and 1, it's going to be expanded. And if the absolute value of A, meaning whether it's positive or negative, is more than 1, so it can be like 2.5, it doesn't have to be an integer, that is a compression. That is an arrow, and it does not look like one. I think I'm making it worse. Okay, so that all of this is given to us by what is in the A position of a quadratic when it is provided to us in this format. What the value in the P position tells us is the x coordinate of the vertex. It gives us the equation for the axis of symmetry, and it tells us whether it's going left or right, and remember we have to do opposite sign on this one because the base formula has it's negative P. All right, and then the number in the Q position will tell us the y coordinate of the vertex. It will tell us the min or max value for the range, and it will tell us whether it goes up or down and how much it does that by. Okay. So our summary. So you can pause the video here, you can write it down, you can rewind and go through it again if you want. Example 3, determine the equation of the following parabolas. Okay. So for this one, you have to look at how much did it move up, how much did it move over, and how much is it compressed. Okay. So the format is always going to be that y equals a times x minus p squared plus q format, and you're going to put values in for A, P, and Q based off of what you can read from the graph. So pause the video here and see if you can figure this one out. So from the vertex, this vertex happens when x is -1 and when y is -4. Okay. So when x is -1, y is -4. So remember what we put in the P position and the Q position have to do with what our vertex values are. Okay, so we get our Q value by what our Y part of our Q is. So it's -4. So it's just -4. We don't have to change anything about that. Okay. But we do have to change something with what our P value is. So instead of writing -1 right here, I do the opposite sign. I do +1 because remember the base equation is -p. So if it's x minus p and we're putting a -1 in for p, which makes it x minus -1, which is x plus 1. So that's why it's x plus 1 squared in that equation. The next thing we have to do is decide what is our A value, okay? So to do this, we have to go, well, how much is it compressed? Normally, if you go 1 away from the vertex, you're gonna go 2 up, or you're gonna go, 1 up, because y equals x squared. So if x is 1, y is 1. So you go 1 up. And this is a little bit more than that. So what you need to do to figure out how much it's compressed is find out what the closest point is compared to the vertex. And you're going to look for how much does it go up for how much it goes over 1. So here's the vertex. I don't know how to make this bigger just for this part. Anyway, so you're going to go over 1 and go up until you find where the parabola is. And it's hard for me to show you this, but it goes up 2. So for every 1 that it goes over, it goes up 2 from the vertex. You have to start the vertex and just find how much it goes up for the first place it goes over. You can't pick another place like up here and do it up here because it's not going to work for you. So if you start at the vertex, you go over 1 and you go up until you hit the parabola. And you have to know how far up did it go before it hit the parabola if you're reading this off a graph. And it went up 2. That means it is compressed twice the amount that it normally would be, because normally it would just be at 1. It goes from the vertex, it goes over 1 and up 1 on the standard model parabola of y equals x squared. So this got compressed 2 times. So it's 2 times compressed. And remember, if the absolute value, positive or negative, is more than 1, it gets compressed. So that means this gets compressed this way, squished this way. That means this is a 2 in the A position. And it's a positive 2 because it opens up. I want you to pause the video here and try the next one. So we have y equals, and I'm going to put some color coding here, something x plus or minus something squared plus or minus something. So we got to find out what goes in those boxes of color. Wonderful color. Okay, so the first one is the first thing we need to do is find out what the coordinate of the vertex is. So the vertex is at right here, and it occurs when x is 0 and y is positive 3. Okay. So that means the Q value is always what the y part of the vertex is. So that means that this is going to be plus 3. the x value of the coordinate gives us what the p value is, the opposite symbol of the p, and it's 0. So it's going to be x plus 0. Okay, and now the part in green is, first of all, it's opening down this time. So we know it has to be negative. And now we have to know how much is it compressed. Okay, and if I go over 1 from the vertex, I only go down a little bit. It looks like I only go down a half. Okay, so to double check that, that means it's compressed by a half, which is the same thing as being expanded by twice the amount. I'm going to go over 2 from here and go down 2. That means I've been 2 times expanded, which is the same thing as putting 1/2 here. Okay, because from this vertex, and again I wish I could blow this up, I went over 1 and then I went down to find where on the parabola it meets, and it only goes down half of a grid mark. So that means the expansion compression factor is 1/2, and it's -1/2 because it opens down. All right, we have another expansion one. Give that a try. So y equals something, x plus or minus something squared plus or minus something. Lots of somethings going on here. So I'm going to add green. All right. So hopefully you got that the vertex here happens at -3, -2. So this is giving us the q value. This gives us the q value. So we can automatically fill those in. This is -2. And technically this is x minus p. So this is x minus -3, which becomes x plus 3. So just remembering to switch the symbol, this becomes x plus 3 in here. It's again opening down. So it's negative. And this is where the figure out the expansion from a graph is really hard. So you go over 1 and it doesn't look very helpful. So the other way to do it is you want to see the next grid line that the parabola directly goes through. And that's going to tell you the expansion factor as well. So the next perfect grid line it goes through is right here. How far over and down is that? So if you count, it goes 1, 2, 3 over and 1, 2, 3 down. So it's a factor of 3, but it isn't compressed. So you can't put a 3 in that green highlighted area of the format. It's been expanded. Remember, expanded is the fraction, so it's over 1/3. And if you go back to the original way of doing it, is find your 1 point, go over 1 and see how far down it goes. It looks like it went down about 1/3 of the way. So it's 3 times expanded, which is 1/3 compressed. All right, so this next part are some word problems. I'm going to pause it here, or I want you to pause it here and try them. Oh, one last thing I forgot to mention is this one over here where it was x plus 0. You could rewrite this one as y equals -1/2 x squared plus 3, because there's nothing in the bracket. You can simplify that and have it written out that way too. All right, so 3 units to the left means that p equals -3. Okay. And it's congruent to this, which means it's the same shape. So it's compressed or expanded by the same factor of 7, right? It's compressed because it's 7, but horizontally compressed. So we're going to write the same thing. So that this gives us our A value. Because it hasn't mentioned anything about being a mirror or moving up or down, we don't have to worry about changing the sign of the number in the A position, and we don't have to worry about having anything in the Q position. So this just becomes y equals positive 7, and then because it moved 3 units to the left, this becomes positive 3 squared. The next one says the horizontal translation of 5 units to the right. So that means P equals positive 5. A vertical translation of 6 units. That means Q equals, it was 6 units down. So Q equals negative 6. And it's congruent to this, which gives us A. So if we're looking at y equals A x minus p squared plus q, all we have to do is pull the information out of what's been given to us and stick those numbers in the correct spot. So the equation for this line is y equals negative 1/5 times x minus 5 minus 6. Try the next one. So it opens downwards, which means A is going to be negative. It's expanded vertically by a factor of 5. So that means it's compressed horizontally by a factor of 5, which means A equals 5. Remember, it's a whole, the absolute value is more than 1 if it's horizontally compressed. Goes up higher. And it's translated 7 units down. So this means Q equals negative 7. Does it mention anything about P? No, it mentions nothing about left or right. So that means there's nothing in the bracket here. P is just 0. So x minus 0, x plus 0 is the same thing. It's just x. So we don't have to write the brackets for this one. This one becomes y equals negative 5 x squared minus, oops, I was going to write q, minus 7. Okay. All right. So this next one is asking you to use Desmos.com to graph the following graph. So even if you don't have a smartphone and you can't get the app, you can go to the website, hopefully. And I'm just going to share my other screen. Okay, so hopefully you can see this. I'm going to Desmos.com. I'm going to start graphing. All right, this is the computer version of it, and I'm going to enter that equation. So it was negative 0.025 bracket D, where am I? Minus 20 squared, I think on here. Oops. There, oh, there it is. It's hiding. I want squared and then plus 10. Oops. Didn't like that. I'm going to change D and put in an X. There we go. Okay, apparently I can't use my own symbols. So there's the parabola. So you could use this also for sketching instead. It's still really good practice to learn how to sketch with the table of values. So it says, what is the maximum height of the ball? So just to review the question, the height of the soccer ball, h in meters, as a function of the horizontal distance, d in meters, the ball travels until it first hits the ground as described by the function h of d equals negative 0.025 times d minus 20 squared plus 10. A whole bunch of stuff. What's nice is the maximum height of the ball is right here. And what you can just tap the screen and it will come up. and all of a sudden it comes up with the value of the vertex, which is the same thing as telling you the axis of symmetry, which is 20, and the max height, or the max value for y, the largest range, which is 10. So the maximum height of the ball is 10 meters because the vertex happens at 20, 10. Okay. What is the horizontal distance of the ball from the kicker when it reaches its max height? So that's asking you how far horizontally did it go? What is the value of x when we have this here? And I can't really draw on this, but I'm going to see if I can. I'm going to be cheeky. There we go. Yeah, look at me writing all over it, not being very helpful. Okay. There we go. So this here tells us the max height occurs at 10 meters. It tells us the distance of which this occurs from the kicker. The kicker is at 0 distance, kicks the ball. It happens at 20. So the answer for B is the distance is 20 meters. How far does the ball travel horizontally when it's kicked from the ground? So until it reaches the ground. So here's where it also reaches the ground because the height is 0. Oh, look at my freeze frame of my face there. That's terrible. All right, so that happens from the distance of the kicker. That happens at 40 meters from the kicker. What is the height of the ball when it is 10 meters horizontally? So 10 is here. So you have to go up to find that value here. And what's nice about Desmos is you can actually slide your finger on the graph and it will tell you the value when x is 10, it will tell you this value of y. And I'm not going to flip back and forth, but it happens at a height of 7.5. So for D, you should get 7.5 meters. And it says, what would an opposing player positioned under the height of the ball, 34 meters, so 34 meters is 1, 2, 3, 4, is right here. It's saying if someone was right here, sorry, this is 2, so 34, 6, 8, yeah, it goes up by 2, is right here, would he be able to head the ball? So, I mean, could he jump up and head the ball? So you need to know, in order to answer that question, you need to know what the height is right here. So that's at 32, right here. You need to know that height. And again, so you just slide your finger before. So you need to know what the height is when x is 34. So very similar to the other question, you need to find that value. You need to find that value for y, and you're going to slide across. And you should get the value of 5.1 meters. So even if he was a 2-meter man or woman or person, they're not likely going to have a 3-meter vertical. Okay, so the likelihood that they would be able to reach a height of 5.1 meters with their head to head a soccer ball is very unlikely. So that's the answer to that one. Okay, so that concludes it. There's some questions from the textbook there. Do what you can for this week, what your circumstances allow. And you might, if you need more time into the next week, that's fine. So it's just kind of more providing you with these lessons as you can do them. So do what you can. If there's a problem or you have questions, please contact me and we can go over them. I hope you're all doing well and I will talk to you soon. Goodbye.